solving absolute value equations. How we can solve an absolute value equation? First of all, what's an absolute value? Absolute value, it's a function that any number that shows the distance from any number from 0. These two little bars, when you put a number inside, when you say the absolute value of 2, which means the distance from 2 to 0, which is 2. When I say what's the absolute value of -2, I mean what is the distance from -2 to 0, which is again 2. Which means that the absolute value's job is make everything positive. Since the absolute value shows the distance, we cannot have a negative number from the absolute value. We can have a negative inside the absolute value, but not the outside. Because the outside number, this number shows the distance from this inside number to 0. And distance never can be negative. And you see in this picture that shows the absolute value of -5, which is 5. And it means that the -5 is 5 units from 0. And the absolute value of 5 is 5, which means that the 5 is also 5 units from 0. But when we solve an absolute value equation, that means the x or the variable must be inside of the absolute value. And when you want to solve an absolute value equation, you say, okay, I am going to find the numbers that the distance of those numbers from 0 is 5. And those numbers can be +5 or can be -5. Which means when you're solving an absolute value equation, you always have two sets of solution, one with the positive, one with the negative, because you are finding the inside of the absolute value. And the inside of the absolute value is always positive. It can be both positive and negative. So to solve any absolute value equation, make sure, first of all, to isolate the absolute value term. After you make sure that the absolute value is by itself in one side of the equation, that's the time that you need to drop the absolute value. And to drop the absolute value, you need to rewrite it as a two different equation, one with the positive, one with the negative, without absolute value. Then you have to solve each of those equations and find the variable. Again, at the end of each equation, we need to check the solution to make sure that and just plug it into the equation to make sure that the answers are giving us a true statement. Let's look at an example. I'm going to follow these steps. Step 1, it says isolate the absolute value term. Okay? When you look at this equation, the absolute value term is this term. You want to isolate this one. When you want to isolate that, that means you need to cancel 2 and you need to cancel -6, because those are the numbers that are on the left side with the absolute value. But something that we know, when we are working with operation, we always follow the PEMDAS. But when we are solving equation or isolating a variable, okay, for isolating, again, we are following PEMDAS, but in a backward direction. That means if you want to isolate something, if there is any add or subtract, you need to get rid of them first. If there is any multiplication or division, that's the next step. Then you look at the exponent or the radicals or anything else or the absolute value. Then inside of the parenthesis or the inside of the absolute value or the inside of the radical. Okay, so now I want to isolate the absolute value. And based on the backward direction of PEMDAS, I need to get rid of any add or subtract. And the only add or subtract that I have on the left side is -6. And the opposite of negative is +6. So I will add 6 to the both sides. So we will have 2 with the absolute value on the left, and 14 plus 6, which is 20 on the right. Now it's time to cancel any multiplication or division. Multiplication or division is 2, because 2 is multiplying by the absolute value. And to cancel 2, I need to divide both sides by 2. That's the opposite of multiplication. So now I have x minus 3 equal to 10. Now I'm done with the step 1, because absolute value is isolated. Step 2 says drop the absolute value. And to drop the absolute value, I need to rewrite it as a 2 separate equation. So we have to have 2 separate equations. We have x minus 3 equal to positive 10 without absolute value, and x minus 3 equal to negative 10. And remember that the other side must be a positive, must receive a plus and a minus. It must be a positive and negative. We never touch the inside of the absolute value. If the inside is x minus 3, it has to stay the same for both. Now we have to solve each of these equations separately. So when I say solve, that means isolate the x. That means you need to move negative 3 to the other side. And to move negative 3, we need to add 3 to the both sides. The same on the next one. Now we say x equal to, because negative 3 and positive 3 cancels each other, and 10 plus 3 is 13. Negative 3, positive 3 cancel each other, so x is equal to, what's negative 10 plus 3, which is negative 7. And we have 2 solutions. You can check the solutions by going back to the equation and plug in 13 for the x and negative 7 for the x, and see if you get the true statement. I will replace one of them for you, but you can check both of them. If I replace negative 7, for example, I will rewrite everything, bring down everything, just replace the x by negative 7. I want to see if I get the true statement or false statement. When I claim that this is a solution, that means I have to end up with the true statement. So first of all, this time I'm working with the PEMDAS in a original direction, because I'm just working with numbers. I'm not isolating something. So let's find the inside of the absolute value. What's negative 7 minus 3, which is negative 10. Then I have to find the absolute value of negative 10. And I know the absolute value's job is make everything positive. So the absolute value of negative 10 is positive 10. No more absolute value. Now I have to do the multiplication, which is 2 times 20. 2 times 10 is 20, and 20 minus 6, which is 14. Okay, so 14 is equal to 14. That's a true statement, so that's correct. And you can also check 13 as well. It must end up with the correct statement, true statement. Let's solve the next equation. Step 1, isolate the absolute value. If I want to isolate the absolute value, since absolute value is on the left side, I need to get rid of 7, move it to the right. And to move 7 to the right, since 7 is adding, I need to subtract 7 from the both sides. So the absolute value of 3x minus 4, which is equal to, what is 3 minus 7? Negative 4. Now absolute value is isolated. When absolute value is isolated, it's time to drop the absolute value. And when you drop the absolute value, you have to rewrite it as a 2 separate equation, one with positive, one with negative. But in this equation, the other side is a negative number. I know that the absolute value's job is making everything positive. That means everything that's outside the absolute value, the other side of the equation, must be positive. But right now, the other side of the equation is a negative number, and there is no way that we get a negative from the absolute value. So every time you isolate the absolute value and you see the other side is a negative number, you have to stop, because there is no way you can find any x that can be replace for x in this equation. So in this case, we say there is no solution because this side is negative, the other side is negative, and it should be positive. And the next equation, first, we have to isolate the absolute value. That's the absolute value on the left side. Okay, so if I want to isolate the absolute value, I have to get rid of -4 and +1. But for isolating, I always follow the PEMDAS in the opposite direction. That means add or subtract is the first thing that must be canceled. And I need to cancel +1 because 1 is adding right now. And to get rid of that, I need to subtract by 1. Bring down everything else that remains. And -11 minus 1 is -12. Now it's time for canceling -4. -4 is multiplying. To isolate the absolute value, you have to divide by -4. So now I have only the absolute value on the left side, and on the right side, -12 divided by -4 gives me +3. Okay? This is a positive number, so I can continue and finish the work. Okay? Now it's time to drop the absolute value, and every time we drop the absolute value, we have to keep the absolute value inside the absolute value the same, 2x minus 3, but the other side can be +3 or can be -3. Now it's time to solve each of them and find the x. To find the x, we have to isolate the x. Isolate the x means get rid of 2 and -3. To get rid of -3, we have to add 3 to the both sides. To get rid of 2, we have to divide both sides. 1x must be 3, +3, and 1x must be 0 divided by 2, which is 0. And you can also go back and plug in the x with 3 or 0 and check your solutions. And the last equation for this section, how we can solve this equation. Again, we follow the steps. First step says that isolate the absolute value. To isolate the absolute value, since the absolute value is on the left side, no other numbers or the variables must be on the left side. And you can see that the absolute value is isolated right now. So we are done with this step 1 because nothing else beside the absolute value is on the left. Step 2, drop the absolute value. To drop the absolute value, you have to write it as a 2 separate equation, one with positive, one with negative, but the positive or negative is for the other side. Okay, so you drop the absolute value and you keep 5x plus 3, but the other side, which is -7x plus 51, must be written as the positive 4 or -4. I'm going to separate them. That means I say, okay, 5x, let me just write it down here. So we say 5x plus 3 must be equal to positive, means distribute the positive. When I say negative, that means distribute the negative. Okay, so negative times a negative is +7x. Negative times positive is -51. Now I have 2 separate equations, and I need to solve each of them. In previous equations, we only had a number on the right side. So you just replace the number with a positive or negative form. But in this equation, the right side it's another equation. It's two terms. So when I say one equation with positive, one equation with negative, that means multiply the whole terms, all of the two terms by positive and negative. If you multiply the whole by positive, nothing change, stay the same. But if you multiply by negative, all the sign will change. Now it's time to find the x. And to find the x, based on what we learned for linear equation, we need to have x terms on one side and constant on the other side. If I want to have x on the left, I need to move 7x to the left side, and I need to move 3 to the right. So we get 12x, which is equal to 48. And now to isolate the x, divide both sides by 12. And the x must be equal to 4. For the second equation, to move 7x to the left, subtract 7x, because 7x is positive. Now you have to subtract it. And move 3 to the right by subtracting 3. So we have negative 2x on the left and negative 54 on the right. And you divide both sides by negative 2 to have x by itself. So the x should be 27. And you can also check this solution by plugging the x 4 and 27 and see if you get the true statement.